Hello everyone, this is Dave the Blender, and in today's video we are going to create a Blender add-on to control, in a much easier way, the procedural signs we built in the previous video. This add-on will let us create signs with a single click, control their parameters, syncing directly with the geometry node's inputs. With this, we'll achieve a much faster workflow, making it easier to create objects and modify them through a simpler UI. In this video, we'll cover the basics of Python for Blender, from operators and handlers to property groups and panels. If this is your first time diving into Python for Blender, don't worry. This video is also for you. Even though the project is pretty simple, it's always a good idea to start with a clear plan. So let's begin with a quick overview of the structure. I want a panel with two sections. The first section will let us create a new sign with a button. This part will always be visible. The second section will only appear when the active object is a sign. In that case, it will display its parameters and allow us to edit them. So what does this mean in Python terms? I need a function to import all my assets from another Blender file included with the add-on. This will bring in the node groups we created earlier, along with some materials and the font. I also need a second function to handle the import process, basically making sure the assets are always available, whether we're working in a new file or an existing project. I need a property that stores the value single post or double post, chosen by the user. I need an operator that creates the sign. That means creating a new object and assigning the node group. This operator will read the previous property to apply the correct modifier, so the selected type of sign is generated. I need a panel to display this property and the operator. I also need a property group that stores the value of the geometry node input sockets. This group will sign with the modifier values whenever a sign is selected, so the current parameters are shown. And if the user edits a value manually, it will update the node inputs accordingly. Finally, I need a second panel to display the values from this property group and allow the user to edit them. Besides Blender's internal classes, we'll mainly program four functions: import assets and schedule import. This will bring the resources from a Blender file to the current project. Update properties. This takes the value entered by the user in the panel and sends it to the corresponding input socket to update their parameter. Sync geometry node to property group. This will sync the geometry node values with the property group. It will run every time the active object changes, so the same property group can display values from any sign in the scene. Before we start coding, let me show you some last-minute updates I made to the node trees. The text sign now has a material assignment section and a highway exit shape. The single pole sign can also use the text sign to add text at the bottom. And with all that ready, we can finally start building our add-on. I'll be using Visual Studio Code for this project. If you want to set up VS Code for Blender development, you can check out these videos. Otherwise, the built-in Blender text editor works perfectly fine too. Here's how I like to structure my project directory. I keep one file per Blender internal class, plus a separate file for my custom functions, where most of the core logic lives. I also have an asset folder that contains my Blender file, in this case, the one with all the geometry nodes. The init file has two main parts: the add-on metadata at the top, and then the registration section, where I can call all the register functions from the different modules. Let's start with the import logic. I will create a function called import assets and define a list with the geometry nodes I need. These are the node groups we created earlier. You can find their exact names in the outliner by switching the display mode to Blender file, and then looking under node groups. This view also shows every resource in the file: materials, textures, fonts, and more. First, I check which node group already exists in the current project, and from there, I build a list of the missing ones. Basically, the assets that still need to be loaded. Now, it's time to import them. I look at the node groups available in the external file, filter only those listed in my nodes to load variable, and append them to the current project. Once imported, I assign them a fake user by setting useFakeUser equals true. Since no object is using them yet, this prevents Blender from deleting them before we actually assign them somewhere. Next, I'll define the schedule import function. Here, I add a custom attribute queued, so I can track whether the function has already been scheduled. If that attribute is false or doesn't exist yet, I trigger the import through a Blender timer that runs after 0.1 seconds. It is important that the function returns none, otherwise Blender would keep calling it repeatedly. Let's move to the handlers file and import both the function and the persistent decorator. We define a function called onloadPost and decorate it with persistent, so Blender doesn't remove it when opening a new file. Then we append it to the loadPost handler, but only if it hasn't been added already. And just like with the registration, we also need to properly remove it when unregistered. So what exactly does the loadPost handler do? Basically, it runs right after Blender finishes loading file data, objects, scenes, collections, everything. That makes it the perfect moment to import our assets automatically. I will also call this function from the main register function, since register runs whenever this add-on is enabled. This ensures that if I disable the add-on and my node groups disappear, they'll be re-imported immediately when I enable it again. Let's test it quickly. I open a new file, check the console, and I can see the import function running. And if I look in the outliner, voila! The assets are there. Now that everything works, I'll extend the function so it also imports materials and fonts. With the geometry nodes available in any project, we are ready to move on to the sign creation. Let's start by creating a property inside a property group that lets the user choose the type of sign they want. For this, we can use Blender's enum property to define a list of options. In my case, I'll add two entries, single post and double post. Just like with handlers, this property also needs to be registered. I'm adding it to the window manager data block. Under the name, road settings. Now, whenever we want Blender to actually do something, we need an operator. I will create one called createSign. Inside execute method, the first step is to read the property we just defined, so the operator knows which type of sign it should generate. Next, I'll create a basic mesh, a simple plane, place at the origin. I'll make this new object the active one on the scene and rename it to sign. To be able to detect whether the active object is a sign, I'll assign a custom property. This property, called type, will store either single post sign or double post sign. You can see it later under the object's custom properties in Blender's interface. Now I define which geometry node group should be applied based on the user selection. The ng variable will reference the correct node group, and using the mod variable, I'll create a geometry node modifier and assign the node group to it. Once everything is done, the execute method must return finished. And of course, we register the class. So far, we have the property and the operator. The last missing piece is the panel that exposes them in the UI. I'll create a main panel called signs. Inside it, I'll access the property group and display both the createSign operator and the sign type property. And as always, don't forget to register the panel. With all that ready, we can jump back to Blender, open the panel, and finally create a nice looking sign. Keep in mind that if something went wrong during the asset import, or if the geometry node name is misspelled, you will only see a plane here, since the node group couldn't be applied. This already looks like a proper add-on, right? Now let's move on to the attributes mapping. I will define a new property group for the single post sign and another one for the double post sign. These groups will store the values coming from the modifier's input sockets. Let's begin with the sign type. I will create an enum property, define a list with the different sign options, and set the default value to 0, the speed limit type. Next, I need an update function. For this to work, we need a mapping between the property inside the property group and the corresponding geometry node sockets. You can find the exact socket name by hovering your mouse over the input field in the modifier. Using that, I'll build two mappings, one for the single post sign and another one for the double post version. Inside the update properties function, I grab the active object and, based on the custom property type we assigned earlier, decide which mapping should be used. The socket name will be retrieved using the field key from that mapping. I'll add a small print statement here, so I can clearly see when the updater runs, which field it targets and which value it receives. I'm also limiting the number of decimals displayed when the value is a float, just to keep the console readable. And now we simply apply the change. I get the geometry nodes modifier, access the desired socket, and update its value directly. Sometimes when parameters are changed from the add-on instead of the modifier UI, the value updates, but the mesh doesn't refresh immediately. In those cases, I'll call update tag on the object to force Blender to refresh the geometry right away. Back in the property group, I import the update function and create a small wrapper update method for this first parameter. I assign it to the property like this, so every time the value changes, it triggers this updater, which then calls the main update function with the correct field and value. In this case, I convert the value to an integer. That's because the property itself is defined as a string, while the modifier expects integer values for list type inputs. To test everything, let's update the panel and give it a try. I'll bring the new property groups into the panel and also grab the active object from the scene. If there is an active object and it has a custom property type, we can filter which UI to display. If the type is a single post sign, I create a layout, add a box, and expose the type 1 property. Let's see how it looks. Now, when I change the value, the updater is triggered with the new data, and the mesh updates instantly. From here, it's mostly repetition. We just need to repeat the same process for the rest of the properties. And after almost 800 lines of property definitions, we are finally done. I've also updated the panel, so it only shows the parameters relevant to the selected topology, making the interface much cleaner for the user. At this point, we can already control the modifier from the property group. Now the next step is doing the opposite, updating the property group based on the modifier. Property group sync. Right now, I have two signs in the scene that I can edit with the add-on. But if I switch from one object to another, the values in the panel don't update. What I want is simple. Whenever I select a different sign, the property group should reflect the current values of that active object. To achieve this, I'll create a function called sync geometry node to property group. Inside this function, I'll need the mapping we defined earlier, the active object, and its geometry nodes modifier. First, I check the object type. If it's a single post sign, I load the corresponding property group and mapping. If it's a double post sign, I switch to the other ones. Then, for every entry in the mapping, I read the value from the modifier socket and assign it to the matching attribute in the property group. I will also print a warning message in case something goes wrong, just to make debugging easier. Now, remember that some of our properties are defined as strings in the property group, but as integers in the modifier, especially the enum property fields. So we need to handle that conversion here as well. I created a small list containing all properties that behave like enums. If that current field belongs to that list, I convert the value accordingly before storing it. At this point, the core logic is done. But here comes the key question. When should this function run? Let's jump back to the handlers file. This time, we'll use the dependency graph handler. It runs whenever something changes in the scene, which makes it perfect for detecting object switches. I'll create a variable that stores the name of the previously active object. Now we need to be careful here. The dependency graph handler can fire very frequently, so we don't want to run our sync function unnecessarily. I'll add a few filters here. There must be an active object. The object must have the custom property type we assigned earlier, and its name must be different from the previously active one. Only if all these conditions are met will the sync function execute. And after running it, I update the last name active variable with a new object name. And let's register it. Back in Blender, if I switch between signs, the panel now always displays the correct values. Exactly what we wanted. And that's it, our Blender add-on is officially finished. If at any point the video felt a bit fast, or you'd like to go through the code at your own pace, you'll find a link in the description where you can download the full project and try everything yourself. I hope you found this both useful and interesting. If you did, don't forget to like the video, subscribe to the channel, and I'll see you in the next one.